Hello everyone, my name is Abdullah. Today I'll hopefully be informing you on the topic of whether or not the Ontario Drive Clean program was effective. Please refer to this slide for your summary uses. Before throwing my obtained statics at you, let's take a look at what exactly is Ontario's Drive Clean program. The Ministry of the Environment introduced the mandatory Drive Clean Vehicle Emission Program in 1999 as part of its strategy to reduce smoke in Ontario as it monitors and repairs vehicles producing too much emissions. The program identifies vehicles whose emissions controls are malfunctioning and it requires that the owners of such vehicles have them repaired. Driving testing requirements coupled with vehicle turnover, better vehicle technology, cleaner fuels, and improved vehicle maintenance are all factors contributing to fewer pollutants in vehicle emissions. However, even the most sophisticated vehicle can become a gross polluter if its emission system is not properly maintained. For our answer, dragline reduced the total amount of smoke causing emissions from light-duty vehicles by about one-third every year. This chart summarizes dragline emissions information to the end of 2012. From 1999 to 2012, dragline reduced smoke causing emissions of hydrocarbons and nitrogen oxide from light-duty vehicles by almost 400,000 tons, as well as emissions of carbon monoxide, a poisonous gas, by more than 3.8 million tons, and carbon dioxide, a greenhouse gas, by about 327,000 tons. In 2011 and 2012, DriveClean reduced the combined emission of hydrocarbon and nitrogen oxides by 32,000 tons respectively. To understand emissions, we need to look at a vehicle's engine. In the internal combustion engine, combustion is the fundamental process which converts the chemical energy of the fuel in thermal energy inside the combustion chamber. This thermal energy is converted to mechanical energy through the engine's internals. In relation to what we know in our chemistry class, the combustion is a chemical reaction between air and the fuel generally composed by a mixture of different hydrocarbon molecules. The reaction can be simplified as seen on your screen. A varying form of octet reacting with oxygen gas and nitrogen gas, yielding us carbon dioxide, water, carbon monoxide, a hydrocarbon, and a form of nitrogen oxide. As you see here, this real-world combustion process is one of your typical cars that your parents may own. You may realize that this is incomplete combustion due to the production of other exhaust gases that you may not find in normal combustion. These gases come in the form of carbon monoxide, unburned hydrocarbon, nitrogen oxides, and soot. Now that we're done with our combustion process, you may ask yourself, how does this relate to our drive clean program? Well, I mentioned that the drive clean program monitors cars' emissions and filtration system when performing the diagnostic. One of these systems is the catalytic converter located in your car's exhaust system. The catalytic converter simply reduces your emissions of the car. In the catalytic converter, there's ceramic. This generally does not do anything but heats up, which aids in the chemical process. The bigger contributors to the chemical reaction are the rare metals platinum, palladium, and rubidium that react with the engine's products or emissions mentioned previously. The first stage takes place in the catalytic, in where rubidium and palladium separate nitrogen oxides into nitrogen gas and oxygen gas through a process called the reduction catalyst. You may realize that nitrogen gas and oxygen gas get shot out of exhaust system the same way it came into the combustion process previously. Now the filtration is not completed yet. The second stage of filtration inside the catalytic converter is oxidation catalyst. This stage has two parts. In the first part, freed freed up oxygen from the reduction catalyst as well as the form of combustion process is pulled in by palladium and platinum in order to bind them with carbon monoxide, creating carbon dioxide. The second part consists of the same oxygen pulled in but combining it with any unburnt hydrocarbons and oxidizing it. As we see from all this, a vehicle's emissions system filters our products the same way as our reactants. Now, for my opinion and final analysis. Even though the Ontario government has cancelled the drafting program, it's extremely crucial for us to do our part in reducing emissions through our transportation needs. We could do this by offering our cars proper care and maintenance of the emission reduction system. Many of the repairs that could be required to be performed may be avoided completely through proper care of your vehicle, and thus have less financial burden on yourself. I strongly believe the program was not worthily effective in reducing our greenhouse gases, but is understandably outdated with today's modern automobile technology. Instead of all these invalid arguments, a great proposal would be to invest in a zero-emission vehicle that should not only be efficient in their preparation, but also in their manufacture and recycling. Here are all my sources used to conduct this research. Thank you for your time.